And Assalamualaikum to everyone. We are from AS1154B. Would like to share our video presentation of chemical thermodynamics. Enjoy! Our team consists of 4 members, which are Nisa Rosafira binti Safian, Farah Hazwani binti Hairusaleh, Siti Zul'Aleesya binti Zulkarnain, and Wan Nurumadisa binti Wan Yusuf.
Hi, my name is Farah Hazwani binti Hairusaleh, and I will discuss on various types of temperature measuring devices. First, we will start with resistant thermometer or resistant temperature detectors. Unlike the more general semiconductor or resistant element, the term RTD has consistently been linked to the particular pure metal detector. These devices are made of pure metal and are extremely accurate and stable. The platinum RTD is a linear device, not a thermistor. Temperature changes its resistance in a straight line. A length of thin platinum wire wrapped around a ceramic or glass core makes up the majority of RTDs currently in use. The element is frequently covered in a sheet material since it is so fragile. The purest possible material was used to create the wire core. The transducer's accuracy is influenced by the metal's purity, while the RTD was commonly made with platinum. Nickel, copper, balco, and tungsten are also the pure material that can be used, even though balco and tungsten are rarely used only for special circumstances. Next is thermocouple. The thermocouple is indeed a very adaptable tool. The measurement area can be as big or as small as needed because the temperature is only measured at the actual interface of two metals. Nowadays, the majority of thermocouples are created by joining two pieces of wire that are not similar. Just by choosing the right size wire, this junction can be as big or little as required. In addition to connecting the two metals together, thermocouples can also be made physically. The two metals must only make good physical contact for this to work. Next is bimetallic thermometer. Compared to a glass thermometer, the bimetal thermometer was created to be a less accurate but more durable measurement tool. There are still numerous industrial applications where knowing the temperature of a fluid or gadget is desirable, but the cost of an expensive probe and readout is not reasonable. Examples of this include gas grills, furnaces, and ovens, as well as cooling water loops. Bimetal thermometers are made up of a thermal element, a scale, and a metal sensing rod that conducts the temperature to the thermal element. The metal component of the bimetal sensor has the shape of a flat spring, and two different metallic materials are placed together to form this element. The last one is infrared thermometer. Spot radiometers or infrared thermometers are made to measure the accurate surface temperature at one relatively small point on a machine or surface. The point of use infrared thermometer can be used in a process monitoring program to monitor the temperature at key spots on plant machinery or equipment in combination with a number of the microprocess or base vibration instruments. The infrared thermometer can be utilized in practically any application between 0 to 3600 degrees Celsius.
Hi, my name is Siti Zul'Aleesya and I will share about the operational principle of each device. The first one is resistant temperature detectors or RTDs work under the premise that changes in temperature cause a metal electrical resistance to very reliable, essentially linearly and repeatedly. RTD have a temperature coefficient that is positive. Resistance increases with temperature. At a constant temperature, an element's resistance is inversely correlated with its cross-sectional area and inversely proportional to its length. An RTD's resistance is measured by a conventional electrical circuit meant to determine the temperature with RTDs. Bridge circuit construction. The basic bridge circuit shown in diagram below consists of a voltage source, a sensitive emitter, 3 resistors which are R1, R2, and R3, an unknown variable resistor and a variable resistor. The relationship between the two bridge arms resistance can be stated as follows. Rx is the sole variable that is unknown because R1, R2, and R3 all have known values. In this case of an emitter with zero current, Rx can be determined for the bridge. Knowing these conductivities give the instrument connected to the circuit element a starting point for calibration. Rx, the identified resistance, is provided as below. Second is thermocouple. The Seebeck effect serves as the foundation for the thermocouple's operation. According to this phenomenon, an electromotive force EMF is produced in a closed circuit when two dissimilar metals are joined at two junctions and junctions are remain at different temperatures. The next one is bimetallic thermometer. The following two fundamental metal temperature properties are the foundation of this thermometer's operation. The physical dimensions of the metals will alter soon as the temperature changes. The metal strip rotates in the direction of the metal with a lower temperature coefficient whenever the temperature rises. Next, we look into infrared thermometer. Infrared light can also be focused, reflected or absorbed just like visible light can. Infrared thermometers use a lens to concentrate the infrared light that an object emits onto a thermophile detector.
Assalamualaikum. My name is Zul'Aleesya. For the next question is to explain its advantages and disadvantages. For the resistant thermometer advantages, it has a good accuracy. Temperature composition is not necessary. The RTD is available in wide range. The stability was maintained over a long period of time. It can be easily installed and replaced. For the disadvantages, the cost of RTD is high, and it also has large bulb size. Low sensitivity occurs in RTD, will be affected by shock and vibration, and also possibility of self-heating. Next is thermocouple. The advantages is simple working principle, short response time, self-powered, small size. For the disadvantages, non-linearity. The next one is less accuracy. Next is old technology. The next is need calibration. Next, interference can cause errors. The third thermometer is bimetallic thermometer. Its advantages are a faultless and durable design, cheaper than other thermometers in price. They are entirely mechanical and run without the aid of a power source. Simple installation and maintenance, suitable for a wide variety of temperatures. For the disadvantages, they should not be used in extremely hot temperatures. They might need to be calibrated frequently. Low temperature readings might not be reliable. When the bimetallic thermometer are used regularly, the bimetallic of the instrument may permanently bend, resulting in inaccuracies. But not least is the infrared thermometer. Its advantages is temperature measurement from a distance. Directly save the detected temperature. The infrared thermometer features a memory that can save each temperature that is measured. Next, moving objects measurement. For the disadvantages is high temperature range is necessary. Lastly, distracted easily while taking temperature. Part C briefly explains its cost. The slide shows the cost for each thermometer. Resistance thermometer costs between 186 ringgit 54 cents to 1,370 ringgit and 7 cents. For thermocouple, the cost is between 42 ringgit and 80 cents to 5,000 ringgit. For bimetallic thermometer, the cost is between 33 ringgit and 60 cents to 6,000 ringgit. Lastly, infrared thermometer costs between 41 ringgit and 30 cents to 3,400 ringgit.
Next, we look into the range of applicability. For the resistant thermometer detectors, RTDs can be utilized from negative 270 degrees Celsius to 850 degrees Celsius. The next one is thermocouple. Thermocouple can be used in either oxidizing or reducing environments. Negative 200 to 350 degrees Celsius is the suggested operating range, but it can even be utilized at negative 269 degrees Celsius. Next one is bimetallic thermometer. Bimetal thermometers features temperature ranges that begin at negative 100 degree Fahrenheit and can reach the highest scale reading of 1000 degree Fahrenheit. The last one we have infrared thermometer. The infrared thermometer can be applied to practically every situation between 0 and 3600 degrees Celsius, where its special properties can transform a seemingly intractable measurement and control issue into a workable procedure.
For the next part, which device would you recommend for use in the following case? For question A, device that can monitor the variations of temperature of a car engine blocks at several locations are thermocouples, thermistors, infrared, and thermometers. These are a few examples of instruments that can measure temperature. Infrared sensor work well for keeping track of temperature changes across an automobile engine block. It's because altering the hue of the light will make it easier for you to notice when the temperature changes. Infrared thermometers offer the benefit of providing quick findings in a testing setting and can monitor heat energy coming from specified engine components. They monitor infrared heat energy that is immediately emitted and do not require direct physical touch. For question B, the device that can monitor the temperature in the furnace of a power plant is thermocouples. It is because they are reasonably priced and have a wide enough temperature range to correctly detect their furnace temperature. A thermocouple is an electrical device that creates electrical connections at various temperatures using two separate conductors. It generates a voltage that is temperature dependent and used to detect temperature. Thermocouples can measure a wide range of temperature, are often affordable, and the parts are frequently interchangeable as a result of standardization. The fact that thermocouples are self-powered is a benefit. The precision of thermocouple is limited since most of them can only measure to the closest degree Celsius.